although there's more of a non-property that water has, it's actually a very important concept when dealing with water. And in fact, all of life kind of depends on the idea that water doesn't mix with unlike substances. So when we say unlike, we mean uncharged or non-polar. We've been talking for a while now about how water has those partial positive, partial negative charges. And because of that, it mixes really well with other positive and negatively charged substances. The positives always go to the negatives, and the negatives always go to the positives. Well, the opposite is true if you have something that is not polar or not charged. Common example, very common example, you see the picture here, oil. Oil is a non-charged substance. We'll talk more about it later in the unit. But oil doesn't have partial negatives or partial positives. It's a very just carte blanche substance, no charge at all, or very little charge at all. So it doesn't mix with water. If you force it to mix, so here someone's taking a needle and kind of poking the oil down into the water, you've noticed it forms droplets. So very similar to how the surface tension of water holds together, the oil droplets do the same thing. They kind of force themselves into, so here's a blown up picture, if we look molecularly almost. The oil clumps together and forms on the inside, and that's how we get an oil droplet. That oil wants to have as little interaction with the water as possible, and so most of it stays in the middle, and then you only have to have a little bit of interaction with the water, because again, water and non-charged or non-polar substances don't mix at all. Again, to minimize that interaction, they kind of form the bubbles that we're used to seeing. And that's, again, it's a non-property more than a property, but it's a really, really important concept. And we're going to talk a lot more about it in the next couple of lessons.